but it's close enough to kind of give you an example of what the previous method looked like versus what the new method looks like. The older method was what's called a wet impingement method, and basically what we do is we bring a stacked sample through and bubble it through water, deionized water in the impingers to collect any condensable material. And then they take that to the lab and they evaporate that off, and any weight gain that is your condensables. The new method is what's considered a dry impingement method. So we basically have the front half of the filter, or the sample train, is dry, but temperature controlled. So we're still getting condensation from the gas stream, but it's the reason for the dry impingement is to eliminate what they call artifact, eliminate artifacts within the sample. If you have a fair amount of, you have sulfates and you have ammonia injection, they'll react within the water to create ammonium sulfates, which can show up as false particulate matter, basically. The new method without the water hopefully eliminates those artifacts.
So basically that's the difference, you've taken out the water.
Correct.
And what's the difference from, there's like 4 impingers. Are they all the same, or are they 2 different things?
There's 2 different types of impingers typically. It's there's a Greenberg-Smith, which is comes down to a point, and then there's a bubble plate. And then there's a modified Greenberg-Smith, which is a straight stem impinger. Obviously, the Greenberg-Smith gives you a little more aeration of your sample through of your gas stream through the liquid. I'm not 100% sure what the reasoning is behind the difference of impingers, but those are the 2 that you typically run.
It's now dry in the new method.
Right, the new ones are just straight, just use a straight stem impinger.
Okay.
And then so the front half is dry. Then there's actually a secondary half of the train that still has an impinger with liquid in it, but that's there for determining moisture content. That's not something we recover or analyze for particulate. So it goes through, comes in, goes through a condenser coil, which we regulate between right around below 85 degrees, but above 65. We'd like to keep it as close. We're supposed to keep it as close to 85, but below the gas stream coming in. Then it goes through a second dry impinger, through a Teflon-backed filter, and then into the back half of the train where it goes through a liquid impinger, and then finally through a silica gel impinger, basically to knock out any residual moisture that might be in there and to protect our equipment from getting water and things like that in it. Any questions?
The filter that's there now is new, right? It's not. That's different from the old one.